When most people think about Earth, they imagine a familiar blue and green planet, a place we've mapped, measured, and studied for centuries. But the truth is far stranger than the picture in our heads. Beneath the calm surface of our everyday lives, this planet is hiding mysteries so deep and dangers so powerful that even scientists struggle to fully explain them. From the fiery heart burning hotter than the sun at Earth's core, to sudden shifts in the atmosphere that can rewrite entire climates, Earth is not the stable, gentle home we like to believe it is. It's a restless giant, constantly reshaping itself, constantly threatening to remind us that we are not really in control. And what's most shocking is how little we actually know. We've explored more of the moon than we have of our own ocean. We've drilled only a scratch into the crust compared to the thousands of kilometers that lie beneath us. We rely on models and guesses, but when it comes down to it, Earth is still one of the greatest mysteries in the solar system. Think about it, entire civilizations have been erased by earthquakes, floods, and eruptions. Climate shifts have rewritten history, forcing humans to adapt or collapse. And yet, what if I told you that some of Earth's most dangerous secrets are not behind us but ahead of us? What if the ground beneath your feet, the air you breathe, and the sky above are all carrying risks and mysteries that could change everything we think we know about the future? This isn't just the story of a planet, it's the story of survival, of shocking truths that scientists are still uncovering, and of rumors so wild they almost sound impossible. But as history shows with Earth, the impossible has a way of becoming real. The story of Earth's beginning is often told like a neat scientific fact. About 4.5 billion years ago, a swirling cloud of gas and dust collapsed under gravity, forming the sun at its center and leaving behind a disk of leftover material that clumped together into planets. Earth, we're told, was just one of those clumps, slowly gathering mass until it grew into the planet we stand on today. It's a simple image, one that fits nicely into textbooks, but the truth is far stranger, messier, and filled with unanswered questions that scientists are still trying to unravel. Because if we look closely, Earth's origin doesn't read like a calm, orderly process. It reads like chaos. In those early days, the solar system wasn't the peaceful place we see now, with planets neatly lined up in their orbits. It was a battlefield, a swirling arena of rock and fire, where newborn worlds slammed into each other, shattering, reforming, and scattering debris in every direction. Earth itself wasn't born whole. It was forged through violent collisions, each one shaping it into something new. And the most shocking of all was the impact that likely created the moon. According to the leading theory, a Mars-sized planet, often called Theia, smashed into the early Earth with such force that it nearly tore our world apart. Debris from the collision was hurled into space, where it eventually clumped together and became the moon. What's left behind is a planet permanently scarred by an impact so catastrophic that it should have destroyed everything. And yet out of that chaos came stability, oceans, and eventually life. But here's where the story gets even more mysterious. Some scientists argue that the evidence doesn't fully match this neat collision theory. For instance, Earth and the Moon share strikingly similar chemical compositions, far too close to be explained by two separate bodies crashing together. This has led to speculation that the impact may have been more complicated, maybe even involving multiple collisions, or that Theia and Earth were already made from the same material to begin with. Others suggest an alternative theory that instead of one massive crash, Earth and the Moon co-formed together from the same swirling mass of material, almost like twins separated at birth. And while that might sound like a minor detail, it changes the entire story of how stable planets form and whether Earth's history is truly as unique as we think. Beyond the Moon, Earth's own chemistry carries clues that make its origins more puzzling. For example, where did Earth's water come from? For years, scientists assumed it was delivered by icy comets and asteroids that struck the planet after it cooled. But newer research suggests that Earth may have had water from the very start, locked inside the rocks that formed it. Some isotopes in Earth's water don't perfectly match those from comets we've studied, raising the possibility that our oceans weren't gifts from space, but instead were baked into the planet's building blocks from the beginning. If that's true, then Earth wasn't just lucky. It was designed in a sense from its first moments to be a water world, and yet no one can say for certain which version is right, and that uncertainty only makes the planet's birth story stranger. Another mystery is Earth's iron-rich core. Why does our planet have such a massive, dense center of metal compared to some of its neighbors? The answer may lie in those early collisions, which could have stripped away lighter materials, leaving behind a planet with a heavy metallic heart. But even here, debates rage. Some believe Earth may have swallowed smaller, iron-rich planets in its infancy, cannibalizing their cores to build its own. If that's true, then Earth isn't just one world, it's many, stitched together from the ruins of earlier failed planets. In a way, Earth is a Frankenstein planet carrying pieces of long-lost worlds inside of it. That idea alone is enough to make us rethink everything we assume about its history. Then there are the wild speculations, the ones that make their way into late-night debates and fringe theories. Some argue that Earth's peculiar chemistry, the balance of elements that allowed life to flourish, is too perfect to be random. Was Earth the result of cosmic luck, or something else? While mainstream science avoids words like design, the improbable combination of circumstances, water, iron, carbon, and stability in just the right proportions, has led some to speculate that Earth's origin might not be as ordinary as we'd like to believe. Could our planet be an outlier, a rare jewel in a galaxy of barren rocks? Or does the strangeness of Earth's beginning suggest that worlds like ours might be more common than we dare to imagine? Even time itself adds to the mystery. We think of Earth as old, merely eternal in human terms, but in cosmic history it's still young. Stars and planets were forming billions of years before ours. That raises a chilling thought. Why did Earth appear when it did? Was the timing pure chance, or was it part of a larger cycle? With our sun and planets forming only after earlier generations of stars exploded and seeded space with heavy elements. If so, then Earth is literally made of star remnants, forged from the ashes of ancient suns that lived and died before we ever existed. Every atom in our bodies, every drop of water in our oceans, is recycled stardust from a universe that had to burn and collapse before Earth could even form. It's poetic, but also unsettling. Our world is both young and unimaginably ancient at the same time. And the story isn't finished. New evidence continues to complicate everything we thought we knew. Meteorites falling to Earth sometimes carry strange isotopes, chemical fingerprints from other parts of the solar system, or perhaps even other star systems. Each one is a reminder that Earth didn't form in isolation, but in a galaxy constantly trading materials, a cosmic marketplace of collisions and exchanges. That means Earth could literally contain pieces of other worlds, fragments of alien planets baked into its structure from the very beginning. Suddenly, the idea of Earth as a single, self-contained planet falls apart. Instead, it becomes a mosaic of cosmic history stitched together from countless sources we may never fully trace. When you zoom out, Earth's origin story stops looking like a clean beginning, and more like an endless mystery, a set of questions that grow deeper the more we dig. Was the moon born in a single catastrophic collision, or through a more complicated dance of impacts? Did Earth's oceans come from icy visitors, or were they written into the planet's DNA from the start? How many ancient worlds were swallowed to create the dense metallic planet we stand on now? And perhaps the most haunting question of all, was Earth's birth a rare cosmic accident, or a common event that repeats across the galaxy, meaning there could be countless Earths waiting to be found? What's clear is that Earth's beginnings were anything but ordinary. They were violent, chaotic, and filled with unlikely twists. The calm, blue world we know today is the product of unimaginable destruction, shaped in fire and impact, tempered in catastrophe. And yet, out of that chaos, something miraculous emerged. A planet stable enough, rich enough, and strange enough to give rise to life. That is the real shock of Earth's origin story. Not just how it formed, but that it formed at all. And as we peel back the layers of that history, we begin to realize that what happened 4.5 billion years ago is still shaping our future in ways we are only starting to understand. When we look at Earth, it feels solid and unchanging beneath our feet. The ground seems firm, dependable, and permanent. But that sense of stability is a dangerous illusion, because what lies beneath us is anything but calm. Earth's interior is one of the most extreme, hostile, and least understood environments in the solar system, a hidden realm of crushing pressures, searing heat, and strange processes that we can only guess at. For centuries, scientists tried to imagine what was inside our planet, and even now, with all our technology, we've barely scratched the surface. Literally. The deepest humans have ever drilled is just over 7 miles down, a fraction of the distance to the core. To put that in perspective, if Earth were an apple, we haven't even broken through the skin. Beyond that, everything we know about the planet's interior comes from indirect evidence, like how seismic waves ripple through the ground after earthquakes, or how Earth's magnetic field behaves. And what those clues reveal is shocking. The Earth beneath us is stranger and more violent than we ever imagined. At its simplest, the planet is divided into layers. Closest to us is the crust, the thin outer shell we live on. Beneath that lies the mantle, a vast layer of hot, slowly moving rock that makes up most of Earth's volume. Deeper still, we reach the outer core, a churning sea of molten metal, mostly iron and nickel. And at the very center is the inner core, a solid sphere of metal, about the size of the moon, glowing with unimaginable heat. Each of these layers is extreme in its own way, but together they create a planet that is both deadly and life-giving. Take the inner core. It is thought to reach temperatures of over 9,000 degrees Fahrenheit, hotter than the surface of the sun. That fact alone should be impossible to believe. How could the inside of a planet be hotter than a star's surface? The answer lies in the immense pressure. At the center of Earth, the weight of everything above compresses the metal into a solid even at those blistering temperatures. The result is a sphere of solid iron and nickel, locked in place, but also slowly growing. Scientists believe the inner core has been expanding for billions of years as the outer core cools and crystallizes around it, releasing heat that drives much of the planet's activity. That growth is subtle, maybe a millimeter a year, but over geological time, it adds up. It means Earth is still changing, still evolving, right beneath our feet. The outer core is just as astonishing. Unlike the inner core, it's liquid, a swirling ocean of molten metal thousands of miles deep. And it is this restless sea of iron that generates Earth's magnetic field through a process called the GI dynamo. The movement of charged molten metal creates electric currents, which in turn produce magnetic fields. Together, these currents build the invisible shield that surrounds our planet, deflecting deadly solar radiation and cosmic rays. Without this shield, Earth's atmosphere would have been stripped away long ago, and life as we know it would be impossible. In other words, the chaos deep underground is the reason we're still alive. The terrifying thought is that this system isn't permanent. The magnetic field weakens and shifts over time, sometimes even flipping completely so that north becomes south. It's happened many times in Earth's history, and scientists believe we may be heading toward another reversal. What happens when the shield weakens? No one fully knows. It could expose us to increased radiation, disrupt satellites, and wreak havoc on technology. All because of the unseen movements of molten metal thousands of miles below us. Above the core lies the mantle, which might sound less dramatic but is no less mysterious. Though it's solid rock, the mantle behaves like a slow-moving fluid over millions of years. Heat rising from the core causes the mantle to convect, with hot rock rising toward the surface, and cooler rock sinking back down. This movement is the engine that drives plate tectonics, pushing continents across the surface, building mountains, and fueling volcanic eruption. Every earthquake, every volcano, every shifting coastline is connected to the slow churn of the mantle below. What's shocking is just how powerful this process is. The plates on Earth's surface move only inches per year, but over millions of years, they can rearrange entire continents. The Himalayas, the Alps, the Andes, all of them are scars of this hidden force. Without the mantle's restless movements, Earth would be a dead, stagnant world like Mars, with no mountains, no earthquakes, and no continents drifting apart and colliding. Life itself may owe its existence to this hidden dynamo, because the constant recycling of Earth's surface has helped maintain the delicate balance of climate and chemistry that made the planet habitable. And yet, the mantle still hides secrets. Deep within it, scientists have discovered strange structures called large, low-shear velocity provinces, giant blobs of rock the size of continents, buried thousands of miles underground. No one knows exactly what they are. Some think they're leftover pieces of the planet that collided with Earth to form the moon. Others believe they're unique chemical reservoirs, carrying ingredients that shaped the planet's evolution. Whatever they are, they suggest that Earth's interior isn't uniform but patchy, a chaotic mixture of ancient and modern material that defies simple explanation. These structures are reminders that we don't really know what's happening deep inside Earth. We're guessing, building models, trying to piece together a puzzle with only a fraction of the pieces. Even the crust, the layer we know best, holds surprises. It's fragile, broken into plates that float on the mantle like ice sheets on water. These plates are constantly in motion, colliding, splitting, grinding past each other. Sometimes they move so suddenly that cities crumble and mountains crack. Sometimes they move so slowly that entire oceans disappear, like the ancient Tethys Sea, swallowed when continents collided. The crust may feel solid, but in reality it is temporary, a thin skin constantly destroyed and rebuilt. Oceans open and close, mountains rise and fall, and the face of Earth never stops changing. From a geological perspective, even the ground beneath us is fleeting. When you put all of this together, Earth's interior becomes less like a calm planet and more like a living, breathing organism. It has a heart of fire, pumping heat outward. It has veins of molten metal, circulating energy. It has a restless skin, shifting and cracking as it rides on the flows below. Every part of the system is connected, and every part is extreme. It's a reminder that the solid ground we rely on is anything but permanent. Beneath us is a world of unimaginable violence, a world we can't see but that shapes every aspect of life above. And perhaps the most shocking truth is how little we really know. We build models of Earth's interior, but they're educated guesses at best. We can't drill to the mantle, let alone the core. We rely on indirect clues, like the way earthquake waves bend and bounce as they travel through the planet. And even those clues raise more questions than they answer. Is the core really solid all the way through, or does it hide layers we don't understand? Why was the inner core seem to rotate at a slightly different speed than the rest of the planet? Could there be unknown materials buried deep below, substances we've never seen on the surface? Every discovery brings new mysteries, and every answer only deepens the sense that Earth is stranger than we dare to imagine. So the next time you stand on solid ground, remember this. Beneath your feet lies a world hotter than the sun, denser than steel, stranger than science fiction, a world we can't visit, but one that controls everything from the movement of continents to the survival of our atmosphere. The Earth we know is just the surface. The real Earth is hidden below, and it is still one of the greatest mysteries in the universe. And if what we've learnt so far is this shocking, then what's waiting to be discovered could change our understanding of the planet forever. When most people think about Earth's defenses, they picture the thick atmosphere or the vast oceans. What almost nobody realizes is that our greatest shield is completely invisible, and it surrounds us every second of every day. The magnetic field, born deep in the liquid metal heart of the planet, is the single reason we're not being stripped bare by solar radiation. Without it, Earth would look more like Mars, a desolate world where the atmosphere has been blown away, the surface blasted by cosmic rays. And yet, for something so vital, Earth's magnetic field is far from stable. In fact, it has a history of behaving in ways that are as mysterious as they are terrifying. At its simplest, the magnetic field works like a giant bar magnet, with north and south poles. But unlike a simple magnet, this field is dynamic, constantly shifting, growing stronger or weaker, expanding or contracting like a breathing bubble of energy. Stretches tens of thousands of miles into space, forming a cocoon called the magnosphere. This bubble deflects charged particles hurled at us by the sun in the form of solar wind. Sometimes those particles get trapped and funnel toward the poles, lighting up the skies in shimmering curtains of green and purple known as the auroras. They look beautiful, but they are actually signs of a battle being fought above our heads every day, a battle we rarely think about. Without this shield, Earth's surface would be bombarded with radiation intense enough to make life impossible. But the magnetic field isn't permanent. And here's where the story gets disturbing. Records locked into rocks show that Earth's magnetic poles have flipped many times in the past. North becomes south, south becomes north, and the whole process can unfold over thousands of years, or in bursts that seem geologically sudden. The last full reversal happened about 780,000 years ago, long before civilization. Scientists say the planet has experienced hundreds of these reversals throughout its history, sometimes as frequently as every couple of 100,000 years. By that count, we may already be overdue for another. The very idea is unsettling, a world where compasses suddenly point in the wrong direction, where navigation systems relying on magnetic data collapse, and where the protective shield that keeps radiation at bay weakens dramatically during the transition. And that weakening isn't just theory. Evidence suggests Earth's magnetic field has been getting weaker for the past 150 years. In some areas, like the South Atlantic anomaly, the field is disturbingly weak, exposing satellites to higher levels of radiation and causing malfunctions. If this trend continues, it could mean we're entering the early stages of a pole reversal right now. Scientists don't know how long such a process would take. It could be centuries, or it could accelerate within decades. Either way, the consequences for a technology-dependent civilization could be devastating. Power grids, satellites, airplanes, even pipelines could be disrupted by surges of radiation we're not prepared to handle. And that's before we consider the impact on life itself. What's even more mysterious is why these reversals happen in the first place. We know the magnetic field is generated by the geodynamo in Earth's outer core, where molten iron and nickel churn like a restless ocean. The exact flows and patterns of this liquid metal determine how strong the field is and where it points. But the outer core is not something we can directly observe. We only have mathematical models, computer simulations, and indirect evidence from seismic waves. And those models are clear on one thing: the field is inherently unstable. It wobbles, drifts, and sometimes collapses altogether before reorganizing in the opposite direction. It's like a heart that skips beats. Only in this case, the skips can last for thousands of years. Then there's the unsettling possibility that we don't fully understand how fragile this shield really is. Mars once had a magnetic field, powered by a molten core much like Earth's. But at some point, Mars's field died. Without its shield, the planet's atmosphere was stripped away by solar wind, leaving behind the barren, frozen desert we see today. Could Earth face the same fate one day? Most scientists think it's unlikely anytime soon, because Earth's core is still hot and active. But the example of Mars serves as a reminder: magnetic fields are not forever, and if ours were ever to collapse completely, the consequences would be catastrophic. For now, the magnetic field continues to protect us, but even in its current form, it has quirks that are hard to explain. For example, the magnetic poles don't stay fixed in one place. They drift. Over the last century, the North Magnetic Pole has wandered hundreds of miles, racing across the Arctic at a speed of more than 30 miles per year. This rapid movement forced scientists to update global navigation models earlier than expected, because the field was shifting too quickly for systems like GPS to keep up. It's a reminder that even without a full reversal, the field can change in ways that disrupt our lives. And the magnetic field doesn't just affect Earth. It interacts with the Sun in ways that shape space weather, storms of charged particles that can knock out satellites, disrupt radio signals, and even cripple power grids. The most famous example is the Carrington event of 1859, a massive solar storm that caused telegraph systems to burst into flames. If a storm like that struck today, with our dependence on electronics, the damage could run into trillions of dollars. Earth's magnetic field would shield us from the worst of the radiation, but not all of it. The stronger the sun's outbursts, the more vulnerable we become. Some scientists warn that it's not a matter of if, but when another storm like that will hit. And if it happens during a period of magnetic weakness, the results could be even more devastating. Beyond the practical dangers, there are mysteries about the field that veer into the realm of speculation. Some fringe theories suggest reversals could be linked to mass extinctions, pointing to coincidences between weakened fields and spikes in radiation exposure recorded in ancient rocks. While mainstream science doesn't confirm this connection, the idea is chilling. Could the invisible force protecting us also be a hidden trigger for evolutionary upheaval? Could shifts in the field have played a role in shaping the history of life on Earth? Even if we can't prove it, the possibility lingers in the background, adding another layer of drama to the story of this unseen shield. The truth is, Earth's magnetic field is both our greatest protector and one of our greatest uncertainties. It is a silent guardian, deflecting invisible storms that rage through space, but it is also a fragile system, prone to chaos, reversals, and strange anomalies. We depend on it completely, and yet we barely understand it. The ground beneath us may feel solid, but the force that keeps us alive is a bubble of energy we cannot see, generated by a liquid metal ocean we cannot reach, controlled by processes we cannot fully explain. That is both terrifying and awe-inspiring. So next time you see the shimmering aurora dancing in the night sky, remember what it really is: a sign of Earth's shield at work, deflecting deadly radiation with a beauty that hides the violence behind it. Remember too that this shield is not permanent, not perfect, and not something we can take for granted. The magnetic field is a mystery still unfolding, and its next move could reshape not just our technology, but the very conditions that make life on Earth possible. And as history shows, when the field shifts, it doesn't ask for permission, it simply happens. When we think of Earth's atmosphere, it's easy to imagine it as nothing more than the air we breathe, a transparent blanket that keeps us alive. But in reality, this thin veil is one of the most dynamic and unpredictable systems on the planet, a realm of staggering extremes and hidden dramas that most of us never realize are unfolding above our heads. It's not just oxygen and nitrogen hanging quietly in the sky, it's a layered shield, a stage for violent clashes of energy, and sometimes a source of mysteries that even today, scientists struggle to explain. And the strangest, this fragile envelope of gases is so thin that if Earth were the size of a basketball, the atmosphere would be no thicker than a coat of paint. Yet that thin layer determines whether we live or die. The atmosphere is divided into layers, each with its own bizarre characteristics. Closest to us is the troposphere, the layer where weather happens, storms brew and clouds form. It's chaotic, restless, and constantly shifting. Above that is the stratosphere, home to the ozone layer that shields us from ultraviolet radiation. Higher still lies the mesosphere, where meteors burn up in streaks of light, followed by the thermosphere, where the northern lights dance, and finally the exosphere, where the atmosphere thins into the vacuum of space. Each layer has its own secrets, its own danger. The air we breathe is just the beginning. The higher you go, the stranger it gets. One of the most dramatic aspects of the atmosphere is its ability to unleash unimaginable amounts of energy. Thunderstorms, for instance, may seem routine, but the average bolt of lightning carries enough power to light an entire city for hours. And lightning isn't fully understood. Scientists know it's a sudden discharge of static electricity between clouds and the ground, but exactly what triggers that first bolt is still debated. Even stranger are rare phenomena known as sprites, blue jets, and elves, mysterious flashes of colored light that burst high above thunderstorms, often invisible to the naked eye. Pilots report seeing them, and specialized cameras have captured their eerie shapes. But their causes remain mysterious. It's as if the atmosphere has its own hidden fireworks, flickering out of reach and beyond explanation. Then there are the so-called skyquakes, booming sounds that echo from the sky without any clear source. These rumbles have been reported for centuries, sometimes linked to distant thunderstorms, sometimes blamed on meteors or atmospheric shifts, but often left unexplained. People describe them as cannon fire, explosions, or rolling thunder that comes out of a clear blue sky. Some scientists speculate they may be caused by sudden pressure changes or shock waves from supersonic jets, while others wonder if they're tied to deep atmospheric turbulence we don't yet understand. Whatever the explanation, they remind us that the atmosphere is not a calm, predictable space, but a restless ocean of air capable of producing phenomena we can't fully explain. The atmosphere is also a battlefield. Every day it shields us from a bombardment of meteors, most of which never make it to the ground. They hit the upper layers at tens of thousands of miles per hour, igniting into fireballs that streak across the night sky. Without the atmosphere, Earth's surface would be pummeled constantly, leaving it scarred and lifeless like the moon. But the protection isn't absolute. Sometimes larger objects break through, like the Chelyabinsk meteor in 2013, which exploded in the atmosphere with the force of 30 atomic bombs, shattering windows and injuring over 1,000 people. The atmosphere saved us from an even worse disaster by absorbing much of the blast, but it was a reminder that this shield, while powerful, is not invincible. Yet for all its dangers, the atmosphere is also a gift. The ozone layer in the stratosphere absorbs most of the sun's ultraviolet radiation, shielding life from deadly rays. Without it, the surface would be sterilized in short order. But this protective layer is fragile. In the late 20th century, human-made chemicals called chlorofluorocarbons began tearing a hole in it over Antarctica. For years, scientists warned of rising cancer rates, damaged crops, and ecological collapse if the ozone layer disappeared. It was one of the first global environmental crises, and to the world's credit, nations came together to ban the chemicals. Since then, the ozone has slowly begun to heal. Still, the episode served as a chilling reminder of how easily the atmosphere can be damaged, and how close we came to a catastrophe of our own making. Even stranger are the climate-altering powers hidden within the atmosphere. Tiny changes in its balance of gases can trigger massive shifts in global temperatures. Earth has gone through ice ages and hothouse periods, all driven by changes in carbon dioxide, methane, and other greenhouse gases. Today, human activity is pushing those gases to levels not seen in millions of years, tipping the balance of the system in ways that could trigger extreme weather, rising seas, and disrupted ecosystems. But even without human influence, the atmosphere has proven to be a volatile force. Ancient records show sudden climate shifts that occurred over mere decades, wiping out civilizations and forcing migrations. Imagine the air around us as a loaded spring, seemingly stable, but ready to snap with the right push. Beyond the big shifts, the atmosphere also hides smaller, more localized dangers. Take microbursts, sudden blasts of air that can slam into the ground during thunderstorms with hurricane-level force, flattening trees and even crashing airplanes, or atmospheric rivers, massive streams of moisture that flow through the sky, dumping torrents of rain when they make landfall. These phenomena are invisible until they strike, and even with modern technology, they can catch us off guard. They are reminders that the atmosphere is not just a backdrop, but an active, unpredictable system that can change lives in an instant. And then there are the mysteries we still can't solve. For example, unexplained luminous events reported by pilots, glowing clouds, strange flashes, or orbs of light that appear out of nowhere. Some of these can be explained as reflections, ball lightning, or rare electrical phenomena, but others remain stubbornly mysterious. The atmosphere is vast and constantly shifting, and it may well be hiding secrets we haven't even begun to uncover. Some speculate that these anomalies could hint at unknown physics, or at least at processes in the upper atmosphere we don't yet understand. Whatever the case, they serve as a reminder that we've explored only a fraction of what happens in the skies above us. For all its power and mystery, the atmosphere is astonishingly fragile. It can be disturbed by volcanic eruptions, which inject ash and gases high into the stratosphere, cooling the planet for years. It can be altered by massive fires, which send plumes of smoke so high they circle the globe, and it can be disrupted by human actions, from burning fossil fuels to launching satellites and rockets. Every breath we take depends on this delicate system, yet every day we gamble with its balance. So the next time you look up at the sky, remember that it is more than just air. It is a shield, a storm, a battlefield, and a mystery. It is filled with invisible dramas that can shape history, topple civilizations, and rewrite the future of life on Earth. The atmosphere is our lifeline, but it is also our greatest vulnerability. And the shocking truth is that for all our knowledge, we are still learning just how unpredictable it can be. Because in the end, the sky above us is not empty space. It is the stage for some of the most powerful and mysterious forces on the planet. The ground beneath our feet feels steady, like the one part of our world we can trust not to move. But that sense of stability is an illusion. Earth's surface is alive, constantly shifting, cracking, and grinding. Every mountain range, every ocean trench, every continent we stand on is carried by massive slabs of rock called tectonic plates, floating slowly on the molten mantle below. They drift only inches each year, but those inches add up to staggering changes over time. Oceans open and close, continents crash together, and entire landscapes are reshaped. The calm we experience on the surface hides the truth. Our planet is restless, and sometimes it reminds us in violent ways. Those reminders are earthquakes, sudden jolts of unimaginable power, born from the hidden movements of Earth's plate. The idea of plate tectonics is relatively new. Less than a century ago, scientists laughed at the suggestion that continents drifted across the planet, but the evidence piled up, matching fossils found on opposite sides of oceans, mountain chains that seemed to continue across continents, and magnetic stripes on the seafloor that revealed new crust forming. Eventually, the theory of drifting plates became undeniable. Now we know that Earth's crust is broken into about a dozen major plates, and several smaller ones, all in constant motion. Where they collide, mountains rise. Where they pull apart, oceans are born. Where they grind past each other, earthquakes strike. It is a system both elegant and terrifying, because it means the planet is never still. Earthquakes are the most direct and frightening result of this hidden movement. They occur when stress builds up along faults, cracks in the crust where plates grind against each other. For years the plates push and strain, locked in place until suddenly the rock snapped. Energy that has been building for decades, centuries, or even millennia is released in seconds, radiating outward as seismic waves. The ground shudders, buildings collapse, and landscapes are torn apart. What makes earthquakes so terrifying is how sudden they are. Unlike storms, which can be tracked, or volcanoes, which often give warnings, earthquakes strike without mercy and without notice. One moment everything is calm, the next the ground itself is betraying you. The scale of their power is almost beyond comprehension. A single magnitude 9 earthquake can release more energy than all the nuclear weapons on Earth combined. The 2011 Tohoku earthquake in Japan shifted the entire country 8 feet eastward and even tilted Earth's axis. The 2004 Indian Ocean earthquake, one of the deadliest in history, unleashed a tsunami that killed more than 200,000 people across multiple countries. These events are not just natural disasters, they are planetary reminders that we are small, fragile creatures living on a restless world, and the worst part is, they are inevitable. The plates will continue to move, stress will continue to build, and earthquakes will continue to strike. Scientists do their best to study these events, but prediction remains nearly impossible. We can map faults, measure strain, and calculate probabilities, but we cannot say exactly when or where the next big quake will happen. That uncertainty breeds fear, especially in places like California, which sits astride the infamous San Andreas Fault. For decades, experts have warned of the big one, a catastrophic quake that could devastate cities like Los Angeles or San Francisco. So far it hasn't come, but the longer the fault remains locked, the greater the tension grows. At some point it will snap, and when it does, the consequences could reshape not just the state, but the nation's economy and infrastructure. And California isn't the only place at risk. Across the Himalayas, the collision of India and Asia builds pressure that has unleashed deadly quakes in Nepal and Pakistan. In Turkey, the North Anatolian Fault runs dangerously close to major cities like Istanbul. In the Pacific, the Ring of Fire encircles the ocean with subduction zones, areas where one plate dives beneath another, that regularly produce some of the world's strongest quakes and tsunamis. Even regions thought to be stable can suffer. In 1811 and 1812, a series of massive earthquakes struck the New Madrid Fault in the central United States, shaking an area so wide that church bells rang in Boston, hundreds of miles away. Earthquakes are not confined to obvious danger zones. They can strike almost anywhere, a reminder that no place on Earth is truly safe. The fear of earthquakes extends into speculation about the future. Some scientists warn of superquakes, rare but catastrophic events far stronger than anything in recorded history. These could be triggered by the sudden release of pressure along enormous fault lines, events capable of devastating entire continents. While such quakes are rare, the possibility cannot be dismissed. After all, Earth is billions of years old, and our brief history has only captured a fraction of its behavior. Who's to say what the planet is capable of when the right forces align? Even more chilling is the connection between earthquakes and other disasters. Underwater quakes can trigger tsunamis, waves that travel at jetliner speeds and crash ashore with devastating force. Earthquakes can also set off landslides, dam rivers, or even awaken volcanoes. In a single moment, one disaster can trigger a chain reaction, compounding the damage and overwhelming any response. The 2011 quake in Japan did not just shake the land, it unleashed a tsunami and crippled a nuclear power plant, proving how quickly one natural event can cascade into human catastrophe. Despite the danger, earthquakes also play a crucial role in Earth's story. They are the price of a living, breathing planet. Without tectonic activity, Earth would be stagnant, like Mars or the Moon. Our continents would not drift, mountains would not rise, and the constant recycling of material between the crust and the mantle would not occur. That recycling is essential. It regulates the atmosphere, maintains climate balance, and even provides the nutrients that life depends on. In a strange way, earthquakes are part of what makes Earth habitable. They are terrifying, but they are also proof that we live on a planet alive with energy. Still, the human cost cannot be ignored. Billions of people live in quake-prone regions, and no technology can stop the ground from shaking. All we can do is prepare, build stronger structures, educate communities, and develop systems to detect the first seismic waves and issue warnings. Japan's warning system has saved countless lives, giving people seconds or minutes to seek safety before the worst shaking arrives. Those seconds may not seem like much, but in an earthquake they are the difference between survival and disaster. And yet, preparation only goes so far. At the end of the day, the Earth moves when it wants to. It doesn't follow our schedules or respect our boundaries. The ground we stand on is a thin crust riding on vast unstoppable forces that have been at work for billions of years. Every earthquake is a reminder of that truth, a message from the planet itself. You may think you are in control, but you are not. So the next time you feel the faint rumble of the ground or hear news of a distant quake, remember this: what you're witnessing is not just destruction, It's the restless pulse of the planet, a sign that Earth is alive, reshaping itself even as we try to carve out stability on its surface. Earthquakes are violent, unpredictable, and deadly, but they are also essential, woven into the very fabric of the planet we call home. And no matter how advanced we become, they will always be a reminder that beneath our feet lies a power we can never tame. Volcanoes are among the most spectacular and terrifying forces on Earth. They rise like sleeping giants from the crust, silent for decades, centuries, or even millennia, only to awaken with explosions so violent they can change the course of history. When a volcano erupts, it is not just a local disaster. It can be a planetary event. Whole cities vanish beneath ash, skies darken for months, climates shift and civilizations crumble. To live near a volcano is to live with the constant reminder that Earth is alive, restless, and willing to remind us of its power at any moment. At their core, volcanoes are simply vents, pathways through which molten rock from Earth's mantle finds its way to the surface. But calling them vents downplays the violence they're capable of unleashing. The magma that rises beneath them is a mixture of molten rock, gas, and crystals under immense pressure. When it finally bursts free, the result can be rivers of lava, towering plumes of ash, and explosions powerful enough to be heard thousands of miles away. Some volcanoes ooze gently, releasing steady flows of lava like those seen in Hawaii. Others erupt explosively, tearing apart mountains, collapsing landscapes, and sending shockwaves that circle the globe. History is filled with examples of volcanic fury. In 79 AD, Mount Vesuvius erupted, burying the Roman cities of Pompeii and Herculaneum under a blanket of ash and pumice. Thousands died, frozen in time by the toxic gases and searing heat. Centuries later, when excavations began, their final moments were revealed in haunting detail, a grim reminder of how swiftly life can be erased. In 1815, Mount Tambora in Indonesia erupted with such violence that it triggered the year without a summer. Ash and sulfur shot high into the stratosphere, blocking sunlight and plunging temperatures worldwide. Crops failed, famine spread, and strange red sunsets inspired art and literature. The eruption killed tens of thousands directly, but millions more suffered in the years that followed as the planet's climate shifted. Even more infamous was Krakatoa in 1883, which erupted with a sound so loud it was heard The explosion sent tsunamis racing across the Indian Ocean, killed over 36,000 people, and darkened skies for years. These were not just eruptions, they were planetary shocks, altering the course of history far beyond their immediate victims. Modern times have seen eruptions just as dramatic. In 1980, Mount St. Helens in Washington state exploded, blasting away an entire side of the mountain and flattening forests for miles. The eruption sent ash across the United States and reminded the world that even in a developed nation, with satellites and seismographs, a volcano can still strike without mercy. In 1991, Mount Pinatubo in the Philippines erupted with a force second only to Tambora in recorded history. The ash cloud rose so high into the atmosphere that global temperatures dropped for years, and the eruption destroyed entire communities overnight. Even in the 21st century, volcanoes have continued to wreak havoc. Eyjafjallajökull in Iceland erupted in 2010, spewing ash that grounded flights across Europe for weeks, stranding millions of travelers and costing billions in economic losses. The eruption itself wasn't deadly, but it showed that even a moderate event can paralyze a modern, interconnected world. And then there are the so-called supervolcanoes, rare monsters that make even Krakatoa or Tambora seem small. The Yellowstone caldera in the United States is one of the most famous examples. It last erupted about 640,000 years ago, and its eruption was so massive that it covered much of North America in ash and likely triggered a global volcanic winter. Scientists estimate that if Yellowstone erupted again at full force, it could devastate agriculture worldwide, collapse economies, and kill billions. Other supervolcanoes lurk around the world, in Indonesia, New Zealand, even Italy. Each one a reminder that beneath the crust, Earth carries weapons capable of wiping out civilization as we know it. Thankfully, such eruptions are rare, but the possibility is always there, waiting silently beneath our feet. What makes volcanoes so fascinating is that they are not just destructive, they are also creative. They build islands, form new land, and enrich the soil with nutrients that feed agriculture for generations. Some of the most fertile regions on Earth, from the slopes of Mount Etna to the valleys of Java, owe their bounty to volcanic ash. Life thrives on volcanic landscapes, turning death into renewal. Even the air we breathe owes much to volcanic outgassing billions of years ago, which helped form Earth's early atmosphere. Volcanoes are killers, but they are also givers, shaping the planet in ways both deadly and vital. Yet for all we know, volcanoes remain deeply mysterious. Scientists can measure gases, map underground magma chambers, and track seismic activity, but predicting eruptions with precision is still beyond our reach. Some volcanoes give clear warnings: earthquakes, swelling, strange gas emissions. Others erupt with little notice. The unpredictability is terrifying, especially for the millions who live in volcanic regions. Cities like Naples in Italy, Quito in Ecuador, or Puebla in Mexico sit in the shadow of dangerous volcanoes, their residents living day to day with the possibility of annihilation. In some cases, people stay because the land is fertile, or because their culture is tied to the mountains. In others, it's simply because they have no choice. But wherever volcanoes loom, they are a constant reminder of Earth's raw, untamed power. Beyond the physical destruction, volcanoes have shaped human history in subtle ways. The collapse of civilizations has often been tied to eruptions that disrupted climate or agriculture. Some historians believe the fall of the Minoan civilization on Crete may have been triggered by the eruption of Thera Santorini around 1600 BC, one of the largest eruptions in recorded history. The blast devastated the region and may have given rise to the legend of Atlantis. Other eruptions have left their mark on religion and mythology, with gods of fire and mountains appearing in cultures around the world. It's not surprising when the Earth itself erupts with fire and ash. It's only natural to see it as the work of divine force. And volcanoes aren't just confined to Earth. Other planets and moons in our solar system also bear scars of volcanic activity. Olympus Mons on Mars is the largest volcano in the solar system, 3 times taller than Mount Everest. On Jupiter's moon Io, volcanoes are still active, spewing lava into space. Even distant icy moons like Enceladus and Europa show evidence of cryovolcanoes, eruptions of water and ice instead of rock and fire. These discoveries remind us that volcanoes are not just a quirk of Earth, they are a universal force, shaping worlds across the cosmos. But here on Earth, the danger remains immediate. Every year, dozens of volcanoes erupt, some small, some catastrophic. Each one is a reminder that the ground we walk on is not solid, but fragile, sitting atop a world of molten rock and unstoppable forces. The question is not if volcanoes will erupt again, but when and where. Will the next eruption be a small display of lava flows, or will it be a planet-shaking event that plunges us into darkness? The uncertainty is what makes volcanoes both terrifying and endlessly fascinating. So the next time you see a picture of a volcano rising silently against the sky, remember this: it is not just a mountain. It is a window into Earth's fiery heart, a reminder that beneath the crust lies a world of chaos waiting to break free. Volcanoes are both creators and destroyers, builders of worlds and bringers of death. They have shaped our planet's past, they shape our present, and one day they may decide our future. Because in the end, volcanoes are the ultimate symbol of Earth itself, beautiful, dangerous, and forever beyond our control. The oceans cover more than 70% of Earth's surface, yet they remain some of the least explored regions of our planet. For all our technology, we have mapped the Moon and Mars in greater detail than the seafloor that lies just beneath our feet. What we do know about the oceans is enough to inspire awe and fear. They are vast, deep, and filled with mysteries that challenge our understanding of the world. The oceans are not just the cradle of life. They are also a theatre of hidden dangers, places where unimaginable forces build in silence before striking with devastating power. At first glance, the ocean may seem calm, a rolling expanse of blue water stretching to the horizon, but beneath the surface lies a world of extremes. The pressure increases dramatically with depth, crushing anything unprepared to withstand it. At the bottom of the Mariana Trench, the deepest point on Earth, the pressure is more than 1,000 times greater than at sea level, equivalent to the weight of 50 jumbo jets pressing down on a single person. In this alien environment, sunlight cannot penetrate, temperatures hover near freezing, and the creatures that live there look like they belong in a nightmare. Bioluminescent fish, giant squid and strange organisms that survive without sunlight remind us that life is adaptable, but also utterly alien in form. The fact that these creatures exist at all shows how little we understand about the full range of life on Earth. But it is not just the strange life that makes the ocean dangerous. It is the sheer energy stored within it. The oceans regulate Earth's climate, transporting heat around the globe through massive currents like the Gulf Stream. These currents shape weather patterns, making some regions livable and others hostile. But if those currents weaken or collapse, as scientists fear could happen due to climate change, the results would be catastrophic. Europe could plunge into a deep freeze, tropical regions could become unbearably hot, and storms could grow even more violent. The oceans are not passive, they are active players in the drama of Earth's climate, and when they change, the world changes with them. One of the most terrifying forces born in the oceans is the tsunami. Unlike normal waves, which are driven by wind, tsunamis are triggered by underwater earthquakes, landslides, or volcanic eruptions. They travel at jetliner speeds across the sea, barely noticeable in deep water. But as they approach land, they slow down and grow taller, transforming into towering walls of water that crash ashore with unimaginable force. The 2004 Indian Ocean tsunami is one of the most tragic examples, killing more than 200,000 people across multiple countries in just a few hours. Entire towns were wiped off the map, and millions were left homeless. In 2011, Japan suffered another catastrophic tsunami after a massive earthquake offshore. Waves as high as 133 feet struck the coastline, destroying cities, killing nearly 20,000 people, and triggering the Fukushima nuclear disaster. These events show the ocean's hidden power, the ability to rise without warning and obliterate everything in its path. Storms born over the ocean are another reminder of its fury. Hurricanes, typhoons, and cyclones draw their strength from warm seawater, spinning into colossal systems that unleash devastating winds and rain. These storms can last for days or weeks, covering thousands of miles, and when they make landfall, the destruction is often catastrophic. Entire cities can be drowned under storm surges, flattened by winds, or cut off by flooding. The cost is measured not only in billions of dollars, but in human lives shattered in an instant. And with warmer oceans, scientists warn that storms will grow stronger, wetter, and harder to predict. The very water that sustains life is becoming a growing threat. The ocean also hides silent killers, currents that drag swimmers out to sea, waves called rogues that appear from nowhere, and whirlpools that spin with deadly force. Rogue waves, in particular, were once thought to be sailors' myths, stories exaggerated by fear, but modern evidence has confirmed their existence. These giant waves, sometimes taller than 10-story buildings, can appear without warning, smash into ships, and vanish just as quickly. Countless vessels may have been lost to these freak waves, their crews swallowed without explanation. Even today, with satellite monitoring, rogue waves remain unpredictable, reminders that the sea can turn deadly in moments. Beneath the surface, the ocean hides even darker secrets. Massive volcanoes lie along mid-ocean ridges, constantly creating new crust as magma rises from below. These underwater eruptions are rarely seen but are some of the most powerful geological processes on Earth. In other places, giant fault lines run along the seafloor, storing tension that will one day be released in cataclysmic earthquakes and tsunamis. The Cascadia subduction zone off the coast of North America is one such ticking time bomb. Scientists warn it could unleash a magnitude 9 earthquake and a tsunami that would devastate the Pacific Northwest, killing thousands and leaving millions displaced. The danger is not theoretical, it is inevitable. The only unknown is where. And then there are methane hydrates, frozen reserves of gas locked deep within the seafloor. Some scientists fear that warming oceans could destabilize these deposits, releasing vast amounts of methane into the atmosphere and triggering runaway climate change. Others worry about the possibility of sudden explosions, where destabilized gas erupts violently from the seabed. While these scenarios are rare and uncertain, they highlight just how little we understand about the hidden threats beneath the waves. The human relationship with the ocean is a paradox. It sustains us with food, regulates our climate, and connects our continents. Yet it also threatens us with storms, tsunamis, and hidden geological dangers. Entire civilizations have been shaped by the sea, some enriched by its bounty, others destroyed by its wrath. Ancient cultures told stories of sea gods and monsters, myths that reflected both awe and fear of the ocean. Even today, with satellite sonar and advanced ships, the ocean keeps its secrets. More than 80% of it remains unexplored. What lies in those dark depths? New species, new resources, and perhaps new dangers we have yet to imagine. For all its beauty, the ocean is a reminder of how fragile we are. A single storm, a single wave, or a single quake beneath the sea can undo decades of human progress. The oceans are not just bodies of water, they are living systems of immense power, systems that do not bend to human will. They are reminders that Earth is still the master, and we are still at its mercy. So the next time you stand on a beach staring out at the endless horizon, remember that what you see is only the surface. Beneath those waves lie forces powerful enough to shake the world, mysteries deep enough to baffle science, and dangers capable of rewriting human history in a single day. The oceans are our planet's greatest treasure, but also its greatest threat. And the truth is, we've only begun to uncover the deadly secrets they hold. Ice might seem harmless, just frozen water, something we toss into drinks or scrape off our windshields on winter mornings. But on a planetary scale, ice is one of the most powerful and dangerous forces Earth has ever known. It can lock up oceans, bury continents, rewrite coastlines, and even reshape entire climates. Ice has toppled civilizations, carved landscapes, and left scars across the planet that remain visible millions of years later. And while today we think of ice as something retreating under global warming, the truth is more complicated and far more terrifying. Because Earth's ice is not just melting, it is shifting, cracking, and preparing to unleash changes that will echo for centuries. For much of the last few million years, Earth has been locked in a cycle of ice ages. Vast glaciers have advanced and retreated, grinding mountains into dust, gouging valleys, and bulldozing anything in their path. During the last glacial maximum, only about 20,000 years ago, massive ice sheets covered North America, Europe, and Asia. They were miles thick, heavy enough to press the crust of the planet downward, changing the shape of continents themselves. Entire species vanished under the crushing advance of ice, and humans were forced to adapt to extreme cold, migrating and inventing new tools to survive. Even today, the Great Lakes, the fjords of Norway, and countless other landscapes bear the fingerprints of this icy past. Without glaciers, Earth would look, and humanity's story would read, very differently. But ice isn't just about shaping land, it holds the power to transform the planet's oceans and climate. When glaciers grow, they lock away vast amounts of water, lowering sea levels and exposing land bridges that connect continents. During the last ice age, humans were able to walk from Asia to North America across the Bering Land Bridge, a migration that shaped history. When ice melts, sea levels rise, drowning coasts and swallowing islands. Even small changes in global ice levels can flood major cities and displace millions of people. And right now, we are in the middle of one of the fastest melts in Earth's history. Greenland and Antarctica are shedding ice at alarming rates, pouring billions of tons of water into the oceans every year. If all of Greenland's ice were to melt, sea levels would rise by more than 20 feet. If Antarctica followed, the rise would be over 200 feet, enough to redraw the map of the world entirely. The power of ice is not just in its bulk, but in its ability to destabilize. When huge chunks of glaciers break off into the ocean, a process called calving, they can create icebergs the size of small countries. These drifting mountains of ice are hazards to shipping, but they are also signs of deeper instability. When ice shelves that hold back glaciers collapse, the glaciers behind them can accelerate toward the sea, unleashing even faster sea level rise. Scientists have already observed this in Antarctica, where the Larsen B ice shelf shattered in 2002 in a matter of weeks. The collapse was a shocking reminder that ice, which seems solid and eternal, can fail catastrophically, altering the balance of the planet almost overnight. And then there is the terrifying link between ice and climate feedback loops. Ice is white and reflective, bouncing sunlight back into space. When it melts, darker land or ocean is exposed, absorbing more heat and accelerating warming. This creates a vicious cycle. More heat leads to more melting, which leads to even more heat. In the Arctic, this feedback loop is already visible. Sea ice that once covered the ocean year-round is shrinking, opening up vast stretches of water. Some scientists warn that the Arctic could be ice-free in summer within decades. The consequences would ripple across the globe, changing weather patterns, disrupting ecosystems and accelerating climate change far beyond what models once predicted. But ice's hidden dangers don't end there. Locked within permafrost, frozen ground in the Arctic, are vast reserves of methane, a greenhouse gas far more potent than carbon dioxide. As ice-rich soils thaw, this gas could be released in massive bursts, triggering runaway warming. Even more alarming are ancient microbes frozen in the ice. In recent years, scientists have revived bacteria and viruses from permafrost tens of thousands of years old. Most are harmless. But what if something deadly were released? What if ice became the source of a new global threat? Not just through climate change, but through disease. It sounds like science fiction, but the possibility is real enough that researchers are racing to study it before thawing accelerates. Ice has also played a decisive role in history. Around 56 AD, volcanic eruptions in a cooling climate led to what some historians call the worst year to be alive. Temperatures plummeted, crops failed, and societies collapsed. Some of this cooling was amplified by ice expanding across the northern hemisphere, reflecting more sunlight and deepening the chill. Later, during the so-called Little Ice Age from the 14th to the 19th centuries, advancing glaciers swallowed farms and villages in Europe. The Thames River in London froze so solid that markets and festivals were held on its surface. The cold reshaped economies, fueled wars, and forced societies to adapt. Time and again, ice has proven itself to be not just a natural phenomenon, but a player in the human story. Looking forward, the threat from ice may be greater than ever. Scientists warn that we may be approaching tipping points, thresholds beyond which ice loss becomes unstoppable. The collapse of key glaciers in West Antarctica could raise sea levels by several meters, displacing hundreds of millions of people. Cities like New York, Miami, Shanghai, and Mumbai could find themselves underwater, their infrastructures destroyed. Island nations could vanish entirely, creating waves of climate refugees and sparking conflicts over shrinking habitable land. Ice is not just a distant, frozen curiosity, it is a ticking time bomb, with consequences that will define the future of civilization. Yet despite its dangers, ice remains breathtakingly beautiful and strangely fragile. Glaciers glow blue in the sunlight, icebergs drift like floating cathedrals, and snowflakes form delicate patterns, no two alike. Ice preserves the past, holding air bubbles that trap records of Earth's climate stretching back hundreds of thousands of years. By studying these bubbles, scientists can see how greenhouse gases and temperatures have shifted through time, offering warnings of what might come next. Ice in this sense is both a destroyer and a teacher, a reminder that the planet's memory is written not just in rocks, but in frozen layers stacked like pages of a history book. And perhaps the most unsettling thought is this: we are living at a crossroads in ice's story. For millions of years, glaciers have advanced and retreated in natural rhythms. Now, for the first time, human activity is altering that cycle. We are melting ice faster than it can grow, tipping the balance in ways the planet hasn't seen in eons. Whether that leads to flooded coasts, runaway warming, or even new ice ages triggered by disrupted ocean currents remains uncertain. But what is certain is that ice is not finished shaping the Earth and us. So the next time you see frost on a window or watch snow fall from the sky, remember that ice is far more than a seasonal inconvenience. It is a force that has buried continents, carved landscapes, toppled empires, and altered the fate of life itself. It is melting now, reshaping the world once again. And the question is not whether ice will change the future, but how, and whether we will be ready when its full power is finally revealed. Life on Earth may seem enduring, but the truth is far darker. Again and again, our planet has wiped the slate clean. Species rise, dominate, and vanish, leaving behind only fossils and faint traces of what once was. Scientists call these moments mass extinctions, events so catastrophic that they reset the course of evolution, erasing the dominant life forms of the time and opening the door for new ones. They are the ultimate reminders that Earth is not a safe or stable cradle for life. It is a planet that periodically reshuffles the deck, and when it does, survival becomes a matter of luck as much as adaptation. The most famous extinction is, of course, the one that ended the age of the dinosaurs. About 66 million years ago, a massive asteroid slammed into what is now the Yucatan Peninsula, releasing energy equivalent to billions of nuclear bombs. The impact blasted a crater over 100 miles wide, threw molten rock across continents, and triggered fires that burned forests to the ground. Worse still, the dust and sulfur it hurled into the atmosphere blocked out the sun, plunging Earth into a kind of nuclear winter. Plants withered, temperatures plummeted, and food chains collapsed. In the end, 3/4 of all species vanished, including the dinosaurs that had ruled the planet for over 150 million years. Their sudden disappearance cleared the way for mammals to rise, eventually leading to humans. In a cruel twist, our existence is tied directly to a planetary catastrophe. Without that asteroid, the world might still belong to giant reptiles. But the dinosaurs' end was only one chapter in a much longer story of extinction. In fact, Earth has suffered at least 5 major mass extinctions, each reshaping life in ways almost unimaginable. The worst of them all happened long before the dinosaurs, around 250, known as the Permian-Triassic extinction, or simply the Great Dying. It annihilated over 90% of marine species and 70% of land species. Scientists believe massive volcanic eruptions in Siberia flooded the atmosphere with carbon dioxide and methane, triggering runaway warming, acidifying the oceans, and choking the air with toxic gases. The seas turned into dead zones, the land became a furnace, and life itself teetered on the brink of obliteration. It took millions of years for ecosystems to recover, and nothing that lived before the Great Dying looked the same afterward. Other extinctions tell their own chilling stories. Around 443 million years ago, the Ordovician-Silurian extinction struck, likely triggered by sudden climate shifts that froze much of the planet, locking water into ice and dropping sea levels. Countless marine species, which dominated life at the time, vanished as their shallow water habitats disappeared. Later, 75 million years ago, the Devonian extinction decimated life in the oceans, wiping out armored fish that had once ruled the seas. Then, 20 million years ago, the Triassic-Jurassic extinction cleared the stage for the rise of the dinosaurs themselves. Each event was like a planetary reset button, erasing dominant life forms and rewriting the rules of survival. What's most unsettling is that these extinctions were not caused by a single type of disaster. Sometimes it was asteroids, sometimes it was volcanic eruptions, sometimes it was climate swings or a lethal combination of all three. In every case, the message was the same. Life on Earth is fragile, and stability is an illusion. Even when ecosystems seem balanced, catastrophe is lurking, waiting for the right trigger to tear everything apart. And here's where the story takes a chilling turn. Many scientists believe we are now in the middle of a 6th mass extinction, one of our own making. Unlike the asteroid that doomed the dinosaurs or the eruptions that scorched the Permian world, this extinction is driven by human activity. Deforestation, pollution, overfishing, and above all, climate change are pushing species to the brink at a rate unprecedented in human history. Studies suggest that species are disappearing hundreds of times faster than the natural background rate, with countless animals and plants at risk of vanishing forever in the coming centuries. Coral reefs are bleaching and dying as oceans warm and acidify. Insects, the foundation of countless ecosystems, are declining in staggering numbers. Large mammals are being hunted to near extinction, while invasive species spread unchecked. Some scientists warn that if current trends continue, half of all species on Earth could be gone by the end of this century. The idea that humanity is driving a mass extinction should be shocking enough, but the consequences go even deeper. Extinctions are not isolated events, they cascade. Remove one species and the predators that rely on it starve. Take away a pollinator, and entire plants disappear. Collapse a reef and the fish that call it home vanish too. The more links we break in the chain of life, the closer we come to collapsing the entire system. And because humans are part of that system, we are not immune. The food we eat, the air we breathe, and the stability of our climate all depend on biodiversity. If the current extinction continues unchecked, we may be writing the script for our own downfall. What makes mass extinctions even more disturbing is how sudden they can be. In geological terms, they happen in the blink of an eye. The asteroid that ended the dinosaurs triggered devastation in days, with after effects that lasted centuries. The Great Dying unfolded over tens of thousands of years, a long time to us but a heartbeat on a planetary scale. By the time the signs were obvious, it was already too late. That is perhaps the scariest lesson of all. Earth doesn't give warnings we can easily recognize, and when collapse begins, it accelerates quickly. And yet, mass extinctions are also paradoxically creative. They erase, but they also open doors. Without the Ordovician extinction, early land plants may never have spread. Without the Devonian extinction, amphibians might never have taken their first steps onto land. Without the death of the dinosaurs, mammals would never have flourished. Extinctions destroy worlds, but they also create new ones. The unsettling question is, what kind of world are we creating now? If humanity triggers a sixth mass extinction, what life forms will rise from the ashes millions of years from now? Will Earth recover with new dominant species, or will our damage be too severe to repair? Mass extinctions also raise questions that brush against mystery and speculation. Some scientists wonder if they follow cycles triggered by patterns in Earth's orbit, changes in the solar system, or even our movement through the galaxy. Others argue they are random, chaotic events with no rhythm at all. Whatever the truth, the fact remains, extinctions are part of Earth's story, and they will happen again. It is not a matter of if, but when. For now, humans stand at a crossroads. We have the power to accelerate destruction, but also the power to stop it. Unlike the species that came before us, we can see extinction coming. We can measure it, track it, and perhaps prevent it. But whether we act in time remains uncertain. The record of history suggests that life will continue, with or without us. What's at stake is not the survival of Earth. It is our survival within it. So the next time you look at a fossil in a museum, remember this. It is not just the remains of a creature long gone. It is evidence of a world that ended, a species that lost its place in the great game of survival. And the chilling truth is that one day someone or something might look at the remains of humanity in the same way, because Earth has reset the clock before, and it will do so again. The only question is whether we'll be here when it happens. When people hear the word climate, they often think of averages, steady patterns of temperature, rainfall, and wind that define regions across the world. But in truth, Earth's climate has never been steady. It is a restless system, driven by the sun, the oceans, the atmosphere, and even forces from deep within the planet itself. Over billions of years, Earth has swung wildly between hothouse conditions, where palm trees grew in the Arctic, and frozen ages where ice sheets stretched to the equator. To imagine climate as stable is to misunderstand the very nature of our planet. What we live through now, mild seasons, predictable rainfall, tolerable heat, is only a brief, fragile balance in a history dominated by chaos. The most striking evidence of this chaos comes from Earth's long dance between ice ages and warm periods. Over the last 2.5 million years, the planet has slipped in and out of deep freezes roughly every 100,000 years. During ice ages, glaciers covered vast swaths of the northern hemisphere, sea levels fell, and ecosystems shifted dramatically. During interglacial periods like the one we live in now, ice retreated, seas rose, and forests spread. These shifts were not random. They were influenced by subtle variations in Earth's orbit and tilt, known as Milankovitch cycles, which changed how much sunlight reached different parts of the globe. A few degrees of tilt or a small change in orbit was enough to tip the planet into a new climate regime, proof of how sensitive Earth's system really is. But orbital wobbles are only part of the story. Volcanic eruptions have thrown the climate into chaos countless times. A single massive eruption can spew ash and sulfur into the stratosphere, dimming the sun and cooling the planet for years. In 1815, Mount Tambora erupted in Indonesia, causing the infamous year without a summer. Crops failed across Europe and North America, famine spread, and desperate people blamed everything from witches to angry gods. The eruption of Mount Pinatubo in 1991 was smaller, but it still lowered global temperatures for several years. These events reveal how fragile our climate is, how one mountain exploding in one corner of the world can ripple across the entire planet. Even more dramatic are the moments when climate shifts on a truly global scale. During the Paleocene-Eocene thermal maximum, about 56 million years ago, global temperatures spiked by 10 to 15 degrees Fahrenheit in just a few thousand years. Scientists believe it was triggered by a massive release of carbon, possibly from volcanic activity, or methane hydrates destabilized in the oceans. The result was a world transformed, polar regions warmed, tropical zones became nearly uninhabitable, and entire ecosystems collapsed or migrated. It took hundreds of thousands of years for the climate to recover. The eerie part, the amount of carbon released then is comparable to what humans are releasing now, only we are doing it far faster. What took thousands of years in the past, we are accomplishing in just centuries, perhaps even decades. Climate chaos has also been linked to some of history's greatest upheavals. The collapse of the Mayan civilization has been tied to prolonged droughts that dried up their reservoirs and farms. The fall of the Norse settlements in Greenland came during the onset of the Little Ice Age, when colder conditions made farming impossible. In China, shifts in monsoons triggered famines that sparked rebellions and toppled dynasties. Again and again, history shows that climate is not just background, it is a force that shapes human destiny, often deciding whether civilizations thrive or collapse. What makes today especially alarming is not just that the climate is changing, but how fast human activity burning fossil fuels, clearing forests, and altering landscapes has pushed carbon dioxide levels to heights not seen in millions of years. The greenhouse effect, once a theoretical concern, is now undeniable. Heat is being trapped in the atmosphere, oceans are warming, ice is melting, and weather patterns are shifting. Storms are becoming stronger, droughts longer, wildfires more intense. Entire regions are facing conditions they have never experienced before, and the impacts ripple through food, water, and energy systems. For the first time in history, humans are not just victims of climate chaos, we are its drivers. The oceans, which act as Earth's great climate regulators, are also shifting in dangerous ways. Currents like the Atlantic Meridional overturning circulation, of which the Gulf Stream is a part, carry heat around the planet, keeping Europe warm and balancing the tropics. But there are signs that this circulation is weakening, possibly destabilized by melting ice pouring fresh water into the system. If it collapses, the consequences would be catastrophic, plunging Europe into deep cold, intensifying tropical heat, and throwing global weather into disarray. Scientists have found evidence that such shutdowns have happened before, sometimes within just a few decades. Imagine winters in London as cold as Siberia, while equatorial regions become unbearably hot. It's not just speculation, it's a pattern written in Earth's path. Another hidden danger lies in tipping points, moments when gradual changes suddenly flip into irreversible shifts. Arctic ice melt is one such tipping point. Once enough ice is gone, the darker ocean absorbs more sunlight, accelerating warming and ensuring the ice cannot recover. The thawing of permafrost is another. Locked within those frozen soils is more carbon than currently exists in the atmosphere. If released, it could drive runaway warming, making human efforts to reduce emissions irrelevant. These tipping points don't just change climate, they lock it into new, harsher states for centuries or millennia. And the effects are not only global but personal. Farmers already face shifting rainfall patterns that threaten crops. Coastal cities confront rising seas and stronger storms. Entire regions from the American West to the Middle East are facing mega droughts that could last decades. For billions of people, climate chaos isn't a future problem, it's a present one. Villages in Alaska are being relocated as permafrost melts. Island nations are planning for the day their land disappears beneath the waves. Refugees displaced by droughts and floods are already straining borders and sparking conflicts. Climate is no longer background noise, it is the main stage on which humanity's future will be decided. Yet even in this chaos, Earth's resilience shows. After every dramatic shift in history, life has found a way to adapt. Forests return after ice retreats. Oceans recover after warming spikes. Species evolve to survive new conditions. But adaptation comes at a cost. Extinctions rise, ecosystems collapse, and millions of years may pass before balance is restored. Humanity, however, may not have the luxury of waiting that long. Our civilizations depend on stability, and the kind of rapid climate chaos now unfolding threatens to dismantle the systems that feed and shelter billions. What's most chilling is how easily we forget that climate has always been unstable. We live in an unusually calm window, a period of relative warmth and predictability that allowed agriculture, cities, and technology to flourish. But that window may be closing. The patterns that gave rise to our way of life are not permanent. They are temporary conditions in a planet's long, chaotic story. To assume they will last forever is to ignore the lessons of Earth's past. So the next time you feel the heat of an unusual summer, or watch storms grow stronger on the news, remember this. Climate chaos is not new. It is part of Earth's deepest rhythm. What is new is our role in accelerating it. Our fingerprints on every rising temperature, every melting glacier, every shifting rainfall. The question is no longer whether Earth's climate will change. It always has. The question is whether humanity will survive the storm of change we are unleashing, or whether we will join the long list of civilizations that underestimated the power of a planet in flux. Invisible to our eyes but vital to our survival, Earth's magnetic field is one of the most mysterious forces on the planet. Generated deep within the molten outer core, this field shields us from the solar wind, a constant stream of charged particles blasting out of the sun at incredible speeds. Without it, Earth's atmosphere would be stripped away in a cosmic heartbeat, the oceans would boil into space, and the surface would be bombarded with lethal radiation. In other words, the magnetic field is the invisible guardian of life. But here's the unsettling truth. This shield is anything but stable. It wobbles, weakens, and even flips entirely, reversing north and south in events that defy human comprehension. And the more scientists study it, the more unsettling the mysteries become. The story begins at the core, a swirling sea of molten iron and nickel spinning thousands of kilometers beneath our feet. This churning motion generates electricity, and from that electricity, a magnetic field emerges, a phenomenon called the geodynamo. It is this invisible cocoon that guides compasses, shapes auroras, and most importantly, protects us from the wrath of the sun. But unlike a steady, predictable machine, the geodynamo is chaotic. Sometimes the field strengthens, sometimes it weakens, and sometimes it does something even stranger. It flips entirely, with magnetic north becoming magnetic south. These reversals happen on average every few 100,000 years, though not on a strict schedule. The last full reversal happened about 780,000 years ago, and evidence suggests we may be overdue for another. What would a reversal look like? It wouldn't happen overnight, but the process could still wreak havoc. As the field weakens in preparation, it could fragment into multiple poles, some popping up in strange places like the equator. During this weakening phase, Earth's shield would be dangerously thin. Radiation from space would bombard the surface more intensely, satellites could fail, power grids could collapse, and the delicate technology we rely on for navigation and communication could be thrown into chaos. Imagine a world where GPS no longer works, planes lose navigation, and power blackouts become common, all because the invisible field that quietly protects us is unraveling. Even without a full reversal, the magnetic field is already showing signs of instability. One of the strangest features is the South Atlantic anomaly, a region where the field is unusually weak, stretching across parts of South America and the southern Atlantic Ocean. Satellites passing through this area are more vulnerable to radiation, sometimes suffering malfunctions or outright failures. Some scientists think the anomaly may be a sign of an impending flip, while others argue it is just one of many temporary fluctuations. But the fact remains, the field is weakening overall, dropping in strength by about 10% over the last 2 centuries. On human timescales, that may not sound alarming, but in geological terms, it is a dramatic change. The mysteries deepen when we look at the history of reversals. Fossilized lava flows capture the direction of the magnetic field when they cooled, leaving behind a record of past flips. What we find in those records is chaos. Some reversals took thousands of years, while others seem to have occurred in less than a century. Some reversals may have even failed mid-process, with the field starting to flip, then snapping back to its original orientation. The unpredictability of these events is what makes them so unnerving. We know they happen, we know they are natural, but we have no idea when the next one will arrive, or what it will mean for human civilization. And the consequences of a weakened or reversed field may go beyond satellites and power grids. Some scientists speculate that mass extinctions in Earth's past may have been linked to magnetic instability. Without a strong shield, cosmic radiation could penetrate deeper into the atmosphere, damaging DNA and increasing cancer rates in both animals and plants. The atmosphere itself could be altered, with ozone layers thinning and UV radiation increasing. While the evidence is debated, the possibility remains. Earth's magnetic field may not just protect us from the sun, but from extinction itself. The magnetic field also carries other mysteries. Why does it reverse at all? Why does it sometimes remain stable for tens of millions of years, and at other times flip rapidly, over and over? Some theories point to complex interactions in the core, where different flows of molten metal compete and destabilize one another. Others suggest that tectonic movements at the surface may indirectly influence the core by redistributing mass and altering how heat escapes. Still others look to the mantle, the thick layer between the crust and core, which may act as a thermal blanket that changes the dynamics of the dynamo. The truth is, we don't know. The heart of the Earth is inaccessible, too deep to drill, and too hostile for any instrument to survive. All we have are indirect clues, scattered data, and computer models that struggle to capture the sheer complexity of a planet's beating heart. Even more mysterious are the anomalies locked into the rocks of Earth's crust. In places like Canada and Antarctica, ancient rocks preserve magnetic fields that no longer match the current one, relics of forgotten flips and failed reversals. Studying these magnetic fossils reveals a history of chaos, one where the field sometimes lingered in transitional states for thousands of years. It also shows that reversals are not evenly spaced. They cluster, they stutter, they surprise. This unpredictability makes planning for the future difficult. We can measure the field weakening today, but we cannot say with certainty whether its signals are coming reversal or just a temporary fluctuation. The magnetic field also connects to one of Earth's most dazzling spectacles, the auroras. When solar wind collides with the field, it funnels particles toward the poles, where they slam into the atmosphere and release bursts of light. The result is the northern and southern lights, shimmering curtains of color that dance across the sky. But auroras are not just pretty, they are warnings of the sun's power. During solar storms, auroras can be seen far from the poles, even in places like Texas or Rome. These storms can knock out satellites, damage power grids, and disrupt communications. With the field weakening, the risk of damage from such storms grows. A strong enough solar storm could cripple global infrastructure for years. And the terrifying part, the sun produces storms that powerful roughly once every few centuries. The last major one, the Carrington event of 1859, set telegraph lines on fire. If such a storm hit today, with billions dependent on fragile electronics, the result could be catastrophic. For all its power, the magnetic field is still a frontier of mystery. We depend on it, yet we barely understand it. We know it shields us, yet we cannot predict its shifts. We rely on it for navigation, yet it betrays us with anomalies and reversals. And lurking beneath all of this is the knowledge that one day the field will flip again. Whether it happens in 100 years or 10,000, the event is inevitable. The question is not whether Earth's magnetic shield will change, but whether humanity will be ready when it does. So the next time you watch a compass needle swing north, remember that you are looking at one of Earth's most fragile illusions. North has not always been north, and one day it will not be again. Beneath your feet, molten rivers of metal churn and twist, deciding the fate of the invisible shield that makes life possible. And when that shield falters, as it has many times before, Earth will once again remind us who is truly in control. For most of human history, the ground beneath our feet has felt like the ultimate symbol of stability. Firm, solid, dependable, but that sense of security is nothing more than an illusion. The Earth's crust is not a single, unbreakable shell, but a patchwork of massive tectonic plates floating on a sea of molten rock. These plates grind, collide, and tear apart, building mountains in some places and ripping open trenches in others. And when the pressure between them grows too great, the Earth releases its fury with devastating force. Earthquakes and volcanoes are the planet's way of reminding us that we live on a restless, shifting world, one that is constantly in motion and occasionally violent enough to reset entire regions overnight. Earthquakes are among the most terrifying of these forces, because they strike without warning, deep below the surface. As tectonic plates press against one another, stress builds over years or even centuries. When that stress is finally released, the ground shakes, buildings crumble, and cities can be reduced to rubble in seconds. The 2010 earthquake in Haiti killed over 200,000 people, collapsing homes, hospitals, and schools, leaving millions homeless in one of the poorest nations on Earth. In 2004, an undersea quake off the coast of Sumatra triggered a tsunami that killed more than 200,000 people across the Indian Ocean. And in 1906, San Francisco was shattered by a quake so powerful that fires raged for days, destroying much of the city. These are not rare, isolated events. They are part of a pattern written into Earth's geology. The same forces that built the Himalayas and the Andes are also waiting, silently, to unleash destruction again. What makes earthquakes even more frightening is that they are nearly impossible to predict. Scientists can map fault lines, measure stress, and estimate probabilities, but no technology exists that can tell us the exact day or hour a quake will strike. Entire cities like Tokyo, Los Angeles, Istanbul, and Mexico City sit directly atop dangerous fault zones, living under a constant shadow. The so-called Big One is expected to hit California one day, a quake powerful enough to topple freeways, rupture pipelines, and kill thousands. The Cascadia subduction zone off the Pacific Northwest is even more chilling. Geologists warn that it is capable of producing a magnitude 9 earthquake, the kind of event that occurs only once every few centuries. When it hits, it won't just be an earthquake, it will trigger a tsunami that swallows coastal towns from California to Canada. The last time Cascadia ruptured was in the year 1700, sending waves crashing into Japan. The next time could happen tomorrow or 2 centuries from now, but the countdown has already begun. Volcanoes are equally unsettling, and in some ways, even more spectacular. When magma rises from the depths, it can build new land, enrich soils and fuel geothermal power. But when it erupts explosively, it can unleash devastation on a scale that dwarfs even the largest earthquakes. Mount Vesuvius buried the Roman city of Pompeii in 79 AD, killing thousands in a storm of ash and gas that preserved their final moments in haunting detail. Krakatoa's eruption in 1883 was so violent it shattered the island, sent shockwaves around the world, and produced sunsets so red and strange that people thought the sky itself was on fire. Mount Helens exploded in 1980, flattening forests for miles, while in 1991, Mount Pinatubo hurled so much ash into the atmosphere that it cooled the planet by nearly a degree for 2 years. These eruptions are reminders that volcanoes are not just local disasters. They are global players, capable of altering the climate and reshaping history. And then there are the supervolcanoes, the sleeping giants beneath our feet that could in a single eruption change the course of civilization or even threaten humanity itself. Yellowstone in the United States is the most famous example, a massive volcanic system that has erupted 3 times in the last 2.1 million years. Each eruption covered continents in ash, blocked sunlight and drastically altered global temperatures. If it erupted today, much of North America would be buried, agriculture would collapse, and billions of people could face famine as global supply chains broke down. Scientists believe such eruptions are rare, occurring only once every hundreds of thousands of years. But rare on geological timescales does not mean impossible within our lifetimes. Other supervolcanoes like Toba in Indonesia, Taupo in New Zealand and Campi Flegrei in Italy are equally dangerous. The eruption of Toba around 74,000 years ago may have reduced humanity's population to just a few thousand individuals, a bottleneck that nearly erased our species from existence. Volcanic eruptions also hide subtler threats. Even small eruptions can release gases like sulfur dioxide, which combine with water to form acid rain, poisoning crops and lakes. Carbon dioxide, invisible and deadly, can seep silently from the ground, as it did at Lake Nyos in Cameroon in 19. These silent killers remind us that volcanoes don't need to erupt explosively to be deadly. They can threaten life quietly, without warning in ways most people never consider. The interconnectedness of these geological forces makes them even more dangerous. An earthquake can trigger a volcanic eruption, as shifting tectonic plates open pathways for magma. A volcanic eruption can trigger earthquakes by shifting massive amounts of weight on the surface. Both can trigger tsunamis that devastate coastlines. These cascading disasters reveal the truth. The threats beneath our feet are not isolated. They are part of a restless system, one that can unleash multiple catastrophes in a single event. And yet, despite their destructive power, earthquakes and volcanoes also give life. Without tectonic activity, there would be no mountains, no fertile volcanic soils, no recycling of Earth's crust. Our atmosphere itself was shaped in part by volcanic outgassing billions of years ago. The same forces that threaten to destroy us are the ones that made life possible in the first place. That paradox is part of Earth's nature. It creates and destroys with the same hand, often in the same moment. The challenge for humanity is how to live with these forces, knowing we can never control them. We build cities near fault lines and volcanoes because those areas are fertile, rich in resources, and strategically located. But in doing so, we gamble with forces far beyond our control. The question is not whether the Earth will remind us of its power, it is when. Every moment of apparent stability is just a pause between catastrophes. So the next time you walk across solid ground, think about what lies beneath. Faults straining under pressure, magma chambers swelling with molten rock, gases building quietly until the moment they burst free. We live on a planet of hidden threats, a world that holds unimaginable forces just beneath the surface. And when those forces are unleashed, they remind us of a truth humanity often forgets. The Earth is alive, and it does not answer to us. For all our skyscrapers, satellites, and sprawling cities, humanity remains one of the most fragile players in Earth's vast story. We like to imagine ourselves as masters of the planet, bending it to our will with technology, reshaping landscapes, redirecting rivers, and even reaching beyond our atmosphere into space. But the reality is sobering. We exist on borrowed time and borrowed stability. The forces of Earth, its shifting climate, its restless geology, its magnetic field, its oceans and ice, dwarf us in scale and power. Compared to these colossal systems, humanity is delicate, our civilizations as temporary as sandcastles before the tide. History is littered with reminders of how quickly the planet can humble us, and yet we often forget how fragile our place really is. Our vulnerability begins with something as simple as the ground beneath our feet. Civilizations rise in fertile valleys near rivers and coastlines, yet those same places are also the most vulnerable to floods, tsunamis, and earthquakes. The Fertile Crescent of Mesopotamia, often called the cradle of civilization, was a land of both abundance and disaster, shaped by floods from the Tigris and Euphrates. Ancient Egypt flourished along the Nile, but a shift in its flooding cycles could trigger famine. Entire empires have fallen when the climate shifted even slightly, or when the ground itself buckled under tectonic pressure. Humanity is drawn to the very places that make us most vulnerable, a paradox of survival that has never gone away. Even today, millions live in cities that could be erased in an instant by earthquakes, volcanic eruptions, or rising seas. Tokyo, Jakarta, San Francisco, and Mexico City are marvels of human ingenuity, but they are also ticking time bombs waiting for Earth to remind us of its dominance. Our fragility also lies in our dependence on stable climate. Civilization as we know it emerged during the Holocene, a relatively warm, calm, and stable period that began about 11. It was this window of stability that allowed humans to abandon nomadic lifestyles and develop agriculture, which in turn led to cities, governments, and technology. But that balance is precarious. A few degrees hotter or colder, a slight shift in rainfall, and entire regions can become uninhabitable. The Dust Bowl of the 1930s in the United States, caused by drought and poor farming practices, displaced hundreds of thousands of people and devastated agriculture. If such a relatively small shift caused so much suffering, what happens when entire climate systems collapse? With modern warming, regions like the Middle East, North Africa, and South Asia could become unbearably hot within decades, forcing mass migrations and sparking conflict. We depend on climate stability, but stability has never been Earth's nature. Even our technology, which we see as our ultimate shield, is built on fragile foundations. Satellites guide planes and ships, predict weather, and connect the globe through communication, but they orbit in a zone vulnerable to solar storms, where a single burst from the sun could fry electronics and cripple global infrastructure. Power grids, too, are vulnerable to geomagnetic disturbances from solar activity, as well as to earthquakes and storms on the ground. A blackout in one region can ripple into global markets, collapsing economies and causing chaos. The more connected we become, the more fragile we are, because one failure cascades into many. We live in a web that appears strong but is, in truth, delicate enough to unravel in hours. Diseases, too, reveal our vulnerability. Ice and permafrost falling in the Arctic are releasing ancient microbes, some dormant for tens of thousands of years. Most may be harmless, but the possibility of a pathogen emerging that humans have no defense against is real. Even within our modern age, with medicine and technology, the COVID-19 pandemic showed how quickly societies can be shaken, economies paralyzed, and borders closed. That was from a virus we could at least fight with vaccines and treatments. What if something emerged that we could not? Earth has hosted countless waves of pandemics across history, and there is no reason to believe the cycle has ended. On a larger scale, the existential threats we face underline just how fragile humanity is in the grand design of Earth. An asteroid impact could erase entire civilizations in hours, just as it once ended the age of the dinosaurs. A supervolcano eruption could blanket skies with ash, causing years of darkness, global cooling, and famine. Shifts in Earth's magnetic field could expose us to radiation, crippling our technology. Rising seas could drown our cities. Mass extinctions, triggered by climate chaos, could unravel ecosystems that sustain us. Every one of these scenarios has already happened in Earth's past, and the planet survived. But survival for Earth does not mean survival for us. Earth has no stake in humanity. It will endure with or without us. Even the systems we consider permanent are fragile illusions. Borders, governments, economies, all depend on predictable environments and resources, yet resources themselves are finite and vulnerable. Freshwater supplies are shrinking as glaciers retreat and rivers dry. Agricultural land is being eroded and poisoned. Fisheries are collapsing under overuse and warming seas. We depend on these systems, yet we strain them to the breaking point. And when they fail, societies unravel. History shows this again and again. The Mayans, the ancestral Puebloans, the Vikings in Greenland, all collapsed when resources they relied upon vanished. We tell ourselves we are different, more advanced, more resilient, but our dependence on fragile systems is the same, only magnified by billions of people and global interconnection. Yet perhaps the greatest fragility of all lies in our perception. We imagine Earth as a background, a stage on which human drama unfolds, but the truth is the opposite. We are the background, and Earth is the main character. The forces that shape this planet existed long before us, and will continue long after. Humanity is a blink in geological time, a brief experiment in survival on a planet that has seen countless life forms come and go. Our fragility is not just physical, it is existential. We believe our cities, cultures, and technologies make us permanent, but in reality they are temporary constructs built on shifting ground and unstable climates. And yet, this fragility does not mean hopelessness. Humanity's strength lies in its ability to adapt, to learn, and to imagine. We cannot control earthquakes or supervolcanoes, but we can prepare for them. We cannot stop ice from melting, or seas from rising, but we can adapt our cities and reduce our impact. We cannot change the fact that Earth will always be chaotic, but we can choose how we live within that chaos. Fragility does not mean weakness. It means awareness of limits, and perhaps that awareness is what will allow us to endure where other species have failed. But the larger truth remains. In Earth's grand design, humanity is fragile. We are guests on a restless planet, borrowing stability from forces we barely understand. Every mountain, every ocean, every storm, and every tremor is a reminder of the scale of Earth compared to us. And in the end, no matter how high we build our towers or how far we send our spacecraft, we remain tied to this planet, subject to its moods and its mysteries. To forget that is to gamble with forces far older and far stronger than ourselves. So when you look at the stars, dreaming of space travel and immortality, remember this. Our greatest challenge is not out there, it is here, beneath our feet, in the fragile balance that sustains us. We are temporary, Earth is eternal, and the real question is not whether the planet can survive us. It will, but whether we can survive the planet. The future of Earth is a mystery filled with both possibility and peril. For all our satellites, supercomputers, and scientific models, we can only sketch the outlines of what lies ahead. What we do know is that the planet is not finished changing. Its surface, its atmosphere, and its life are all still evolving, shaped by forces too vast and complex for us to fully control. What will Earth look like in 1,000 years? In 1,000,000? In 1,000,000,000? These questions may seem impossible, but scientists have begun to piece together fragments of the puzzle, and what they reveal is both awe-inspiring and unsettling. In the near future, the greatest question is how Earth will respond to the pressures humanity has unleashed. Climate change is already altering coastlines, intensifying storms, and reshaping ecosystems. If current trends continue, the next century could see rising seas swallowing entire cities, displacing hundreds of millions of people. Regions that have supported life for thousands of years may become too hot to survive in, while others may be drowned or dried into deserts. Agriculture will be forced to move to new lands, triggering conflicts over resources. This is not speculation. It is already happening. The question is whether we will adapt quickly enough to avoid collapse, or whether Earth's future will be marked by cascading failures of food, water, and shelter. But climate is only one layer of the story. Beneath our feet, tectonic forces continue their slow but relentless motion. In 50 million years, Africa will slam into Europe, closing the Mediterranean Sea and building a mountain range rivaling the Himalayas. The Atlantic Ocean will continue to widen, while the Pacific shrinks, until eventually a new supercontinent forms. Geologists have given it names like Amasya, Novo Pangaea, or Pangaea Ultima. When it arrives, it will rewrite coastlines, climates, and ecosystems across the globe. Life as we know it will be scattered, reshaped, and forced to adapt yet again. Humanity, if it still exists, will be just one more witness to the endless dance of continents across time. On even longer timescales, the sun itself will begin to change. Stars evolve, and ours is no exception. In about 1 billion years, it will grow hotter, enough to trigger a runaway greenhouse effect. Oceans will evaporate, the atmosphere will thicken with steam, and Earth will become a hothouse more extreme than Venus is today. Long before the sun swells into a red giant, our planet may be unrecognizable, its surface scorched and lifeless. If life is to survive, it will need to leave Earth behind, spreading into space before the sun makes the planet uninhabitable. The irony is profound. Earth nurtured life, but in the end, it will destroy it, not out of malice, but as a natural consequence of cosmic evolution. Speculations about Earth's future also reach into the unknown. What if the magnetic field, already weakening, collapses completely during a reversal? Could radiation levels rise enough to cause mass extinctions? What if a supervolcano erupts within the next few centuries, plunging the planet into volcanic winter just as populations are at their peak? What if a massive asteroid like the one that killed the dinosaurs finds its way to Earth's surface again? Each of these scenarios is possible, and each could drastically alter the path of civilization. The unsettling truth is that Earth's future does not depend solely on us. We are at the mercy of planetary and cosmic forces far beyond our control. Yet, for all the dangers, the future of Earth is not only about destruction, it is also about resilience. Life has survived 5 mass extinctions, countless climate shifts, and planetary catastrophes. After each collapse, it has rebounded, often in surprising ways. The future could see entirely new forms of life evolve, adapted to climates and conditions we can scarcely imagine. If humans endure, they may learn to manipulate the environment more effectively, geoengineering climate, harnessing volcanic energy, or even controlling tectonic shifts. Such ideas may sound like science fiction, but so would electricity or space travel to our ancestors. The story of Earth's future may not be written only by natural forces, it may also be shaped by human ambition, for better or worse. But perhaps the greatest unknown is whether humanity will even be here to witness that future. Civilizations rise and fall, often undone by the very environments that nurtured them. The planet does not promise permanence. If we fail to adapt to the changes coming, our chapter in Earth's history could close as abruptly as the dinosaurs. Future species may walk the planet, dig up our ruins, and wonder who we were and why we disappeared. To Earth, it will make no difference. The planet will continue turning, growing mountains, raising storms, and carving valleys long after our monuments have crumbled. At the same time, Earth's future may hold mysteries we cannot yet imagine. What if there are cycles of planetary change we have not yet discovered? Some scientists speculate that mass extinctions may be linked to Earth's movement through the galaxy, as it passes through dense regions of cosmic radiation or dark matter. Others wonder if unseen forces beneath the core could trigger shifts we have yet to detect. Even with our technology, we have explored only a fraction of Earth. The oceans remain largely unmapped, the deep crust unexplored, and the mantle and core completely inaccessible. The greatest discoveries about Earth's future may come not from the sky, but from the hidden depths of our own planet. What's certain is that Earth's story is far from over. It is a planet in motion, restless and alive. Mountains will continue to rise and fall, seas will advance and retreat, climates will swing between extremes, and life will evolve or perish in response. Our species has been here only a moment, but in that moment we have transformed the planet more than most forces in history. Whether we continue as stewards or become another cautionary tale depends on choices we make now. Earth's future is not fixed. It is a spectrum of possibilities, from collapse to adaptation, from extinction to resilience. And perhaps the most humbling thought of all is this: Earth does not care. It is not a mother, not an enemy, not a guardian. It is a planet, obeying the laws of physics and chemistry, following cycles written across billions of years. To us, those cycles mean disaster or salvation. To Earth, they are simply the way things are. The future will come, with or without us. The question is whether we will be wise enough to claim a place in it, or whether we will vanish, leaving Earth to reset once again. When we step back and look at the story of Earth, it becomes clear that we have never truly been in control. The ground beneath us shifts without warning. The oceans rise and fall with devastating force, the ice advances and retreats in cycles that reshape continents, and the skies themselves are governed by chaotic patterns that can warm or freeze entire civilizations. From the hidden power of Earth's magnetic field to the restless churn of its molten core, from the violent history of mass extinctions to the fragile balance of climate, this planet has always reminded us that we are small participants in a vast and unpredictable drama. Humanity, for all its achievements, has survived only because Earth has allowed it, offering a rare moment of stability in a history otherwise defined by upheaval. But that stability is never permanent. Every comfort we enjoy is balanced on the edge of forces far greater than ourselves. The past shows us that Earth is capable of sudden resets. Whole species, entire empires, and even entire ways of life have vanished in the blink of a geological eye. Dinosaurs once ruled this planet, believing, in their own way, that the world would always belong to them. Civilizations like the Mayans, the Romans, and the Vikings thrived for centuries before crumbling when the planet shifted beneath them. Today, we live in an age of unprecedented power, able to split atoms, harness electricity, and send machines into space. But in the face of Earth's storms, quakes, and cycles, we are still fragile. The same planet that gives us fertile soil, breathable air, and flowing water can, without warning, strip it all away. The illusion of control is comforting, but it is just that, an illusion. And yet in that fragility lies the challenge, and perhaps the meaning, of our existence. Unlike any other species before us, we have the ability to recognize these dangers, to study the planet's past, to glimpse possible futures, and to prepare. Earth will continue its dance of chaos and renewal, whether we endure or not, but our survival depends on whether we choose awareness over ignorance, humility over arrogance, action over denial. We cannot stop the tectonic plates from moving or the sun from heating, but we can build smarter, adapt faster, and respect the power of the world that holds us. The story of Earth is not just one of destruction, it is also one of resilience. Life has endured 5 mass extinctions, countless climate swings, and unimaginable catastrophes, and each time, something new has risen from the ashes. The question is not whether Earth will survive, it will. The real question is whether we will still be here to tell the story. Will we learn from the warnings written in the rocks, the ice, and the fossils? Or will we repeat the mistakes of those who thought their world was permanent? The answer lies not in the planet, but in us. Earth has already shown it does not wait. It shifts, it burns, it freezes, it resets. If we want to endure, we must remember that we are not masters of this world. We are guests. Guests in a house built on fire, ice, and storms, where every moment of calm is a gift, not a guarantee. So, as you look at the stars, dreaming of other worlds and distant futures, don't forget the one beneath your feet. This planet has shaped you, sustained you, and challenged you, and it will continue to do so long after you are gone. Earth's story is far from over. The only question is whether humanity's story will remain a part of it, or fade into another forgotten chapter buried in the endless cycles of time.